Hello everyone. This session we can talk about antenna and the wireless bridge. We have four part: antenna basics, outdoor APs, accessories, installation, wireless bridge, and configurations. So for the antenna, for let's say is a name rule. We have the lots of antennas all follow these rules. First the antenna and the second field is indicate which frequency support 2.4G or 5G. And this is the gains and is omnidirectional or directional antenna. And SMA or the N, that's mean the type of this connector. And the P3, this means how many connectors. Some antenna only have the one connectors, some antenna have three, some have two, some have the four. So this antenna you have this is the indoor AP antenna. It supports 2.4G and 5G, and this is the gain omnidirectional SMA connectors, and have the four connectors, one, two, three, four. And this is the indoor directional antenna, and this is the omnidirectional antenna for outdoor, and the connector is N type, only support 2.4G, and this is for the 5G outdoor antennas. And this is the directional antennas, the panel one. And this is the for the point to point wireless bridge. We call it the parabolic dish antennas. So this is the 10. We already see the topology, these pictures in the before. Intentional radiator, and in here we connect the antennas, and here is the feeders. So for antennas, most important by the gain, like these antennas increase how many dBi for the signals at the low base. Sometimes we also call it as a main lobe. So uh, for example, this is the one antenna. This is omnidirectional antenna. In the verticals, it still have its low base. So this is the peak direction, maximum radiation direction. So in the two sides, they have the decrease for the 3 dBi. This is antenna penters, omnidirectional antenna in the side view and the top-down view, the directional side view, top-down view. For this omnidirectional antenna, it's like this kind of antennas we already said. The horizontal is 360 dB, and for this over vertical link, for the vertical link is like really like around 50 degree. This is the patch or panel antennas. This is parabolic dishes antenna. So let's see the outdoor accessories and these installations. This is antennas. These are N-type connectors. For this antenna, coverage is around 100 meters actually. The 150 meters is the maximum. So this is gain. The patch antennas cover less than the 200 meters. This is the gain 40 dB, and the vertical is 60 degree, and horizontal is 65 degree. This is the feeders. This is lightning arrestor. Lightning arrestor is recommend accessories for the outdoor APs installation. Yeah. and there is power ejectors, PUE ejectors, and for these waterproof mods and glue or tapes to do the waterproof after we install the AP. This is our APs. So usually we use these Ethernet ports for the PoE input, and in some project, if we use the fiber, we can use this port. So this is how we do the installation. This is the bracket. So this is installation examples. So this the pool is very important. So this pool sometimes is provided by the partner, sometimes provided by the end user themselves. So this is for the omnidirectional antenna, omnidirectional antenna, omnidirectional antenna, directional antenna. So for this outdoor installations, the recommend is like the pool, especially the pool for the AP is around 550 to 80 millimeters, and yeah, this is for the pool. This is the pool for outdoor AP. This is the pool for the omnidirectional antenna. This is for the directional antenna. Now let's see the wireless bridge design and the installation. For the wireless bridge, it is you see the wireless frequency to connect the user's LAN area without the wire, because sometimes from the one place to another place hard to deploy the cables, so we use the wireless for the bridge. For the Sundrays, uh, this wireless bridge can be up to 10 kilometers. So in this wireless setup, we have one root AP. You can see this root AP is connected to the use the wire connect to this switch, and then on the other end we use the client AP. This client AP have the signals, the terminals connected, and the uplink used to the wireless bridge for the backhaul. Okay, for one wireless project, the process is like we get their requirement and do the site survey, and then we design. When we do the design, we do the AP sizing, solution design, antenna sizing, and then we do the installation. But before the installations, we need to check the configuration. Okay, when we do this requirement analysis, we need to check the distance, if there's the light outside, and what kind of terminal we connect to our wireless bridge, and the what is requirement for the throughput, and also uh, about this requirement, like when you use this wireless bridge, what kind of service you need to carry, if you want to like use camera, if they need the HD video, about time delay. This is about requirement. So the when we know its requirement, we can go the site, do the site survey. For the site survey, we need to better we get the area map, or we can use Google Earth to check, and we need to check where is the distribution of the stations, bandwidth requirement for the wired connection. For the AP's uplink, we need to configure use the fiber or the Ethernet cable, and we need to figure out how many opticals between the client AP and the root AP, and also interference, and also how the APP powered, and the AP positions. And when we do the site better we take lots of pictures around that AP. Then we can do this sizing, code tower size survey, and choose how to do the wireless bridge antennas. So for the APs, we have the outdoor, indoor, and this is the vehicle APs all support the wireless bridge. But for the inward AP, it cannot be used as Clyde AP, so you know this. So for the wireless bridge, we support the point-to-point, point-to-multi-point bridge. We also can support the relay. Yeah, the relay we have type A that we use the two APs for the relay, and we have type B that only one AP work as root and client at the same time. So for these antenna sizes, the omnidirectional antenna is not recommended for the wireless bridge, so this is very important. For this, we see the 1 kilometers, we can use the patch or panel antennas for the wireless bridge. And if this is more than 1 kilometers, we recommend to use these parabolic dishes antennas. So for the relays, if these users stress uh, bandwidth requirement or the throughput is not that high, you can use one AP for the root and client at the same time for the relay. But if they have the higher requirement for the throughput, we need to use the two APs, one is client, one is root. So when we deploy this wireless bridge for the when we do this kind of these installations, we check that place without have obstacles in this uh, free nozzle. The free nozzle requirement is like mm, the obstacles, the ridge be blocked by the obstacles cannot be exceed 40%. If this exceeds 40%, the stability of the leak cannot be guaranteed, and it is generally recommended that free nozzle are blocked by no more than 20%. So here is the notes for this wireless bridge solution design. First one, we need to keep our AP away from this strong electric and magnetism source. That's like no, if there is too many interference, we cannot install the AP. Also, the equipment have the reliable power supply, and recommend use 5G for the wireless bridge. And for the cable to the APs, we need to have extra 5 meters so we can do the adjustment in the future. And when we do the installation, if the ports connector is not be used in your project, better to cover it and tape it with the waterproof uh, the dust. We need to use the tapes to protect the RF port, and we'll also make sure there has a visual light of sight between the bridge APs. And now let's see these installations. For the installation, first step, we do the horizontal direction alignment. So you need to make sure that Glide AP face to the root AP properly. When the distance is a little bit is large, we need to find a reference object. For example, we want to build up the wireless bridge from the building to the building, so the building can be our reference object. So this is for the horizontal direction. For the vertical direction, because we need to make sure root AP and glide AP in the same uh, highness. So this one we can use a Google Earth to calculate what is their highness. And then third steps we do the fine tuning. This one we can use some software to check the signals. And the first steps we do the signal analysis in our controllers, APs. From that we can see that the signal changes and find the best solution, best position, the direction for the APs. Also for this installation, we need to do the supervision for the installation teams because they are maybe not they didn't know too much about uh, wireless bridge, so we need to make sure that they install the AP properly and do the water proof protections and the lightning protections, and the antenna is be fixed firmly. So now let's say the wireless bridge configuration. For the configuration, first uh, I'm gonna talk about in the fit mode, and also we will show the configuration the fat mode. So when we do the configuration, first we approve this root AP and the client AP both in the controllers, and then we do the configuration. In the root AP, we configure the username, configure SSID and the password, and client the same. And then we remove this client AP, remove its wire connection, and then we check if this client AP can be online through the wireless. If it can't be online, that means this wireless configuration is correct. This is the root AP's configuration. So we just choose the AP, same thing. In a repeater bridge, we configure this by the root AP, set up the BSS ID, set up SSID, the password, and then is the client AP that we choose it's a client AP. And then we can set the standards and this WLAN standards in the RF service. We check the build up the wireless bridge to each other. Here the signal stress is the minus negative 57 dB. So that is good. This is the FAT AP. The FAT AP, we just go to the wireless bridge, we set up the root AP, set up the client AP, and in the standards, system standards, we can here check about this wireless bridge. So the wireless bridge, if this uh, cannot bridge up, so the reason is like the AP not face to each other properly, and there has opticals also maybe have the interference, and we can check is the SNR from our controller or the APs. For the configuration nodes, first we need to do the configuration before we do the installation. This is very important. If we didn't do the configuration first and then we did the installation, so we need to pull it down and do the configuration again. And also if you want to change the configuration in the root AP or the client AP, so first we need to change the client AP and then we change the root AP. For the wireless bridge, we use the 5G for the wireless bridge, and the U1 AP cannot use the as a client AP. And also our one AP can be root AP and the client at the same time in the relay scenario. For the bridge, we recommend use a directional antenna. And for the wireless bridge SSID, it's generally recommended to be hidden. Okay, thank you. This is for the antenna and the wireless bridge.